For those who are just come in, I'd just like to say hi to you and ask you how you guys doing today. Okay, today I would like to share with you a concept of called natural language processing. It's a branch of artificial intelligence that deals with the how we can interact with computers through our natural language, like the way we talk, me and you, or your relatives or your friend, because computer is considerably to be non-intelligent. So today I would like to share with you NLP. Nltk is actually a library, a Python library that actually comprises of which is acronym for Natural Language Toolkit. It actually enables programs or computers to work with natural languages. It could be Chinese, it could be Russian, it could be Germany, it could be any Spanish or any other big languages actually have been listed there. There you go. So we were here, so we were discussing about the Nltk, which is a popular library. I'm positive from my knowledge, since I've been engaging with the NLP. There are two popular languages, which there's this Nltk, there's another one called Sparsy. So today we'll go, our presentation will be based on an LTK, which is the Natural Language Toolkit. The library is capable of performing certain operations. We have tokenizing, stemming, classification, parsing, tagging, semantic reasoning. At the end of the this presentation, we have a demo that kind of like based on the semantic reasoning. Tokenizing is actually basically is if you have a sentence, let's say, I'm going to the market, then I have to, it gives us an ability to break down, to turn the sentence into a list. So I will be position 0, for example, here. So we're breaking down the sentence, could be a sentence, could be a paragraph, or it could be a document. It could be individual words. You see, like, I live in Nairobi. Tokens are I live in Nairobi. So I will be the same thing. I know every one of you is pretty much familiar with the arrays. So we have 0, position 1, position 2, position 3. Lists work the same way as the indexing in list is actually the same as indexing in any other languages. So why do we tokenize? Maybe you are interested to find out. Maybe I have, there was one day actually, I'm kind of like, sometimes I read Bible. I took one of the scriptures, I believe in the Old Testament. I was trying to find out how many times maybe the David name comes up in, I think it was the book of Samuel or something like that. For people who are not familiar with the Bible or coming from a different religion or faith, This is not meaning to offend you. Can actually use it anyhow. So this was just an example. We can count the number of words in the text. So there, there's many other things you actually can do with tokenizing. So in regular Python, we can actually use the keyword strip. You can actually, if there's a comma or you want every, whenever there's a a full stop, you want to make a maybe a sentence, just like an item in an array, definitely you can do that by specifying the name of the sentence, the variable name, then the strip, then actually that's another way of tokenizing. But Nltk has its own way of tokenizing. For instance, like here's how we import the library on. It has to be introduced on top before using it. So from Nltk, we say not tokenized, and inside tokenized, we have import word tokenized. If we wanted to tokenize the sentence, then we'll say sentence tokenized. So this is text founded in here, yeah, then species building a self-sustaining city on Mars, and Neo, SpaceX went F Falcon here. Then we say word tokenized. This is the syntax, how to use it, a text. Then the output will be this way. Then it will create a list uh, for every spaces here, then word tokenized will actually create a list. You see, like uh, there's every word actually. I'm sorry. After 2002, you see comma has been tokenized by itself, SpaceX, and so. I believe is quite understood. And you see the full stop in the end is actually tokenized by itself. Therefore, now we come up with another keyword that we had mentioned from the Nltk library, which supports. It's called stemming. Stemming is coming from the stem, like for those who are familiar with farming, stem is like mzizi, if I'm not mistaken, or shina, or somewhere there. So therefore, for instance, we have different words like running, ran, and so forth. The stem for word running is actually run, R-U-N. Ran, which is R-A-N, stem still be R-U-N. So there are different kinds of stemming. We have a Porter stemmer, Snowball stemmer, Lancaster stemmer. With my knowledge, since I'm not very saying like not a guru in this concept, it's actually pretty familiar with these three. Porter stemma, which is doesn't cut much of the words, it kind of keep the meaning the same way. Kind of keep the English word kind of like they'll be understood by the reader. Snowball stemma is actually is there to support any other languages, like I mentioned before. Like if you want to do Russian, maybe I'm not pretty sure about Swahili, but people are doing NLP in Swahili, and I'm pretty positive that's probably they'll be using snowball stemma. Lancaster stemmas is pretty much strict meaning that it can cut away to the point that that word is no longer understood. So we'll probably go with a few examples here. Stemma is the same way, it comes from LTK, um, uh, like we had mentioned before, is coming from the Nltk library, which is stem. Then inside of it, we have a porter stemma, and the other two, um, like, yeah. So like I mentioned, like you see here, cuts has been removing S, they're getting rid of S. So to get back to cat, which is actually the root of the word cats. So here we create an object from the class porter stemma. Here's just we create a list, connects, connecting, connections, connected, connection. I think I made a mistake here. It's actually, no, it's right. This is connections. Connectings, connect. So therefore, this is the for loop that will give us a chance to iterate word after word. So we start with connects. So connects will, we'll print word, then we'll pass in the syntax for, this is just a regular syntax for Python is quite understood. Uh, then we use this object to get to stem. Then we'll pass in the word. So we'll start with connects, connecting, connections, and so forth until the end of the list. I believe we went through a few, not all of them, so that we can have an understanding. Connects, go back to connect, connecting, go back to connect, connection, still go back to connect, connected, still go back to connect. All these are actually the root of all these words, or the stem of all these words is actually connect. So that was porta stemma. In snowball uh, stemming is actually was created actually, in my belief, to perform NLP for give actually will be able to allow any other languages actually to be people who are doing any other languages, let's say Russian or Spanish, Chinese, they can actually use this snowball stemmer so that they can actually stemming. I mean, they can actually do stemming. And what we're doing, I mean, before I can go far, what we're doing stemming is actually stemming is part of the what we're doing like data preparation before we insert into a model. So for people who are familiar with machine learning, will be like maybe removing some, um, taking care of some of the missing data. Maybe there's irrelevant data, you want to get rid of it because it doesn't help much in actually um, um, in your model. So it will be wise to actually get rid of them. So now it's the same thing. We'll create I mean, an instance, which is snowball from the snowball stemma, and we'll pass in the language, which is English we're dealing with, so that we can actually relate with the previous one, which was a porter stemma. We use the word generous, generate, generously, generation. So then we'll try to see what the actual stem for each word. I mean, in the other word, what's the root of each word? Words. Then we'll do the same thing. We'll use a for loop to iterate the list. Then we'll print a word, which is on this side, then this arrow, then we use on our instance, then stem word. Since it's a snowball stemmer that we instantiate here, we'll know that we are using our snowball stemmer. So we see generous kind of remain the same way, generate, got rid of the E, which is actually it's not an English word, unless I'm missing something. So this is kind of like strict. That's what they call strict. Generously is generous, which is correct. Generation is generat, so which is actually that's what it gave us back, which I don't believe it means anything or this two means anything. So um, we can go on to the next one, Lacan's stemming. This is only English, as far as I know. Lancaster stemming is straightforward. Is actually is excessive stemming. That is actually overcutting words to get to the its root. Overstemming renders stems non-linguistic or meaningless. So you might use stemming using this word. What you might get back is actually being meaningless. So we can go through the same process. We instantiate the same way using the class Lancaster stemmer. We're passing our list. Then we iterate. Iterate. We go through each word in the list. Then we actually we'll be printing each word on this side and what we have got. Eating is actually true. Its stem is actually eat. Eats come from the word eat. Eaten has actually come from the word eat. Puts is actually coming from the word put. Putting is actually come the word put. It's actually kind of did pretty good. And let's show you something else here. If I can get to NLP, and I'll get back to this slide. Sorry about that. A great comparison is here. I'm sorry if I'm taking a little bit longer. We're comparing Portostemma and Lancaster stemma, which is strictly English. Here we can have a quite well comparison between the two. We're past to friend, friendship, friends, friendship, stable, stabilize, destabilize, misunderstanding, railroad, moonlight, football, um, then print. This is just this top part. Then word is hello. Okay. So I was trying to compare between the two. We can actually see comparison between Porter stemma and Lancaster stemma. Like I was saying, actually, Porter stemma is actually strict, meaning that it can overstemming words to a point that those words are meaningless. So we can see here, friend is actually I did pretty good on both of them. Friends, friendship. Potostemma kind of kept the friendships. Potostemma kept friendship. And then Lancaster stemma went to friend. Stabil, this one went to get rid of the I and indicate stabil, which doesn't mean anything. Destabilize, destabil, kind of actually Potostemma kind of. So you get the picture of what I was trying to say. Like when I meant like it does excessive stemming, there's actually overcut words to a point that words are no longer understood. Let me go back to the slide. So let me share a quick thing here. And this is the when you're trying to stemming a sentence. Let's say Pythoners are very intelligent and work very Pythonly, and here their way to success. You see, Pythoners kind of kept the same way. This is Potostemma. Will actually do pretty good. Very intelligent and work very Pythonly, and now kind of kept almost the same sentence of as we had received. If we did to using Lancaster, it actually could come up different. I'm pretty sure. So let's go back to the slide. Sorry for that. So now we are talking about natural language processing. Like we mentioned, is a subfield of computer science, and which is part of artificial intelligence, like I mentioned when I was starting. It gives a chance to understand computer computers to understand what we speak. Like if I say habari gani, then computer will understand like I'm saying habari gani. So somewhere, one way or another, computer will get habari gani in the binary digits. So we'll go through all that, I believe, today. Um, Application of NLP. Many people are pretty much familiar with speech recognition, sentiment analysis, if that's what we're going through today. Sentiment analysis may say you have said the word, we'll be able to categorize maybe, oh, this is a harsh sentence. Maybe this is a nice sentence. If somebody say, hey, welcome, come on in. Okay, that might be a nice sentence. Or maybe, oh, it's you again. Definitely you'll be able to categorize between those two sentences, one being harsh, one being welcoming a sentence. It's capable of summarization of text, question answering. Will be able to feed a lot of questions with their corresponding answers. If I'm accurate about the explanation, if I made a mistake, please let me know. That's the point of learning. Chatbot, anybody who have came across like a website, you going in there, maybe you're browsing. Last time we started talking about NLP, then I got cut off with that. Just few slides. There were a few slides left before the actual demo, but I would like to talk about in natural language processing, there are words that actually they're usually removed during the pre-processing the pre-processing process. I'm sorry, it's kind of sound weird. Then these are the words that don't add or any meaning to a sentence, even if they get removed in a sentence, because the whole concept behind NLP is making the computer to understand the human language. Habari, then we can say habari gani, sijambo, then and so on. So it's just giving a computer ability. Okay, so I think stopwords are the words that do not add meaning, or if they don't have any impact if they get removed from a sentence. That's what they stand for. So is, at, which, on, these are few examples of the stopwords. The who take that, actually, even if they get removed from a sentence, doesn't change the whole semantic of a sentence. Then we have n-grams. Remember we talked about tokenizing. That's actually breaking a sentence, turning a sentence into a list. So n-grams is actually is the same thing as the if I'm not correct, I can be actually corrected. It's actually the same thing as tokenizing, but instead it gives you a chance to combine few tokens to have a semantic or a meaning of a group of words. N actually stands for an integer. It can be 1, it could be 2, it could be 3, it could be 4. But for one is just a gram, and I believe for two is by gram, and three is 3 grams. Then from four, then we start. We'll go over a few example. Example by gram. So you see, like we started with this was was actually a sentence. If you look at it, did you actually broke down to this sentence was like, did you know there was a tower where they look out to the land to see the people? Then actually these words, if you look at the patterns, actually start did you, then you comes up here, then again no, then no starts here, there, and until you get the whole sentence. 3 gram is actually, now you have 3 words instead of two. Now you have three. Did you know? Then you will start here in the beginning, then no, and so forth until the whole sentence is finished. So this is all the way they created this. The is actually to try to get the meaning from the sentence. And Nlp pipeline is actually is a breakdown the process how actually from data is actually I mean, when we get the data, we have to clean the data, we have to pre-process, we are feature engineering, we put in the model, we evaluate, we deploy, we monitor, and updating. Some of the stuff is actually pre-advancing in this pipeline. At my level, I haven't got there yet. I know how to, of course, everybody will be familiar with data acquisition. Text cleaning is actually needs a little bit of a knowledge and modeling for people who went through machine learning or neural networks. Probably they'll probably have an idea what I'm talking about. Oops, sorry. This is kind of elaborate how I just went over. Then in NLP actually can do spelling correction. I've come across different type of people. They're actually using NLP. People from financing, people from doctors, and people they used to go over their documents. So actually, for those, if you do remember, we went over those languages that actually supported directly. I know Swahili can be supported too. Like Russia, sorry, I didn't mean to say Russia first, but English, Chinese, maybe. Um, those are the words actually you put your document, and NLP can actually do the spelling check for you. So like we went over uh, like we went over last week. I mean, a few weeks back, we mentioned that the two libraries actually I'm aware of. There's Nltk, which I'm going to demo today, and Spacey. So even Microsoft actually they use the Microsoft they released the REST API, which uses a Python language and potentially NLP for doing the spell checking. There you go. So now I'll show you the demo. What we can do here. Sentimental analysis. Sentimental analysis. Okay. So this is sentiment analysis is actually trying to analyze the maybe a mood of a sentence. Let's say, hey, come here, maybe rude or not rude, nice, not nice. Is actually trying to get the feeling of a sentence. That this sentence maybe is abusive, or does this sentence use bad words? Does this sentence maybe contain some fraudulent text, like those people who are doing sending people fraudulent messages, like to try to scam them for money. Nlp actually help analyze that, if I'm not mistaken. So we'll go over the whole notebook, actually, pretty much. We are doing sentiment analysis on the IMDb data set. IMDb is actually for those who movie fans. They know that IMDb actually is contains reviews for movies. So now we'll try to understand if this is a good review, is a positive review, or a negative review. So we imported some of the libraries, which I don't want to go over them, because if you're not familiar with Python or machine learning, will probably not be adding so much to you. So I downloaded the data. I imported the file, the CVS file. This is the IMDb dataset, CSV. Then I had to pick through the first three three data. So this is the actual review, and actually this is a positive review. So the data has about 50,000 reviews. Then in other languages, we had to create an empty, in other languages we probably call array, but actually here we call a list in Python. So we'll have a negative review list, which are pretty much, they're both empty. So my goal is actually to go over those 50,000 data, and I'm sorry, I'll probably go back. Here's the target, which is a sentiment, which is positive or negative, like I mentioned before. So I'm trying to separate the positive reviews and put them in the positive review bucket, or a list, or an array in the languages, and negative reviews and put them in their own list. So I iterate over using the length, which will probably go over like 50,000. But then sentiment, which is the target, the column. Then I'll go over every index. If it's positive, then I'll add to the positive review list. If it's negative, then I'll add to the negative review list. Then I went over and just picked through the picked it through the length of negative reviews and saw that there are 25,000, meaning that the other 25,000 I left them in the positive review list. So since there are so many data and in the to train our model now is actually for demonstrations purposes or for learning purposes. I had to just take only 1,000 data, meaning in a word of array is meaning from index 0 to index 999. The positive reviews and negative reviews. So now I have a totally new list. So example, like checked in the last review, positive review, says Gary is superb. So seeing the word superb, I know this is the positive review. Great singing, excellent soundtrack. I know that this is definitely positive. So going over the pre-processing, like I went over the Stopwords, went over the tokenizing, I went over the few other things that actually I went over a couple of weeks ago, or for people who are familiar with NLP, probably will not be so will not be something new in our ears. Then I had to import the library, which is Nltk corpus. Within corpus, then we can find the stopwords. I have a documents. These are totally new empty list. So there's a way in Python. So since we are only interested in getting the sentiment analysis, meaning that we were dealing with adjectives, we're not gonna worry about the verbs, we're not gonna worry about the nouns. So the um, uh, the type actually adjectives in is called POS, POS tag if I'm not mistaken, is recognized by the word J. So allowed word types is J. So whenever you see an adjective, we'll probably go over the code. I'm not meaning to go over every line, but um, so now we go over the positive bucket. Since we created two in the few lines above, then documents who append in Python world, there's is like a set. I'm not sure to call them. Uh, uh, then we'll have a word. Then we'll have a label. If this is since this is a positive review, we'll label it with a POS, meaning that is positive. Now we'll have to remove all the unnecessary punctuation and all that, only to remain with capital letters or small letters only through the I mean I believe this is on every language, how to some people they use in the validating forms in JavaScript or maybe in Java, or it could be PHP, it could be any other languages. Now we have a list of stopwords. We create a list for we create a list, and we we iterating to the tokenized, which is this one here. Then we check if this word is not in stopwords, then we put in a new list called stopped. Then Positive tag, that's what I was talking about. Post tag helps you to know the if this is a noun, this is a verb, this is whatsoever in the part of speech. I wasn't very good in the English class, so cannot go over them, but I'm only interested in adjectives, like I've mentioned before. So for that being positive, then we'll append all words, then we'll lower, make them all small letters. We do the same thing for the negative reviews. We'll create there's a word kind of went out from me. It's like a set. It has it takes two words. Then each index will contain a set of a word and a flag. Since we dealt with the positive reviews, now negative reviews will be known with NEG. Same thing, we had to clean, get rid of the punctuations and stuff, and remaining with only capital letters and small letters. Then we'll tokenize, like we went over, break down the list into single words. Then we did the same thing as we did in the positive reviews. I'm not going to overlap because just a repetition. In Nltk, it gives you a chance to know how the frequency, how the words, how many times it had appears. Using the frequent dist method, we passed all the words that we created above. Then we know that in always in the frequent distribution, that the word good appeared more than any other words. It appeared 1,045. Bad is the next word, great, and so forth. Like the list can actually plainly explanatory. It returns in the world of Python a dictionary, but in the world of JavaScript will be an object, if I'm not mistaken. I'm not sure about other languages. Then we plot these words and see. I'm only interested in 30. Then 30 words actually. Cumulative for those who have been in statistics, cumulative is actually marked as false. So pretty much like visualizing what we had created. So now I'm only word features. So I'm going over all the adjectives. I'm only interested only in thousands. The first 1,000 words, word features. As you can see, these are all adjectives that have been created. We have first, classic, experimental, high, and so forth. These are the only adjectives that we had actually we were only interested in to look at it so that we know the a sentiment of a movie, if is a negative or positive. Then we created a function which this is all part of the pre-processing. This is just a list which passes each word. Category, that's the positive or negative. Then we'll go over this set, a review category in documents which we created above. Then we pass into this function, and this function will return W in words, meaning that this is the Boolean, will be either true or false. Then will be feature, which will be the actual word, which is pretty much the same thing as the object. It will be having a key and a value pairs. Then we have to shuffle for the purpose of avoiding overfitting. Overfitting, Madam Gladness, if I'm not mistaken, it means like making the machine not cramming stuff so that is actually learning through cramming. It doesn't get trained as it's supposed to. Now I'm creating a training set and a testing set. Training set, that's the one I'm actually gonna put in the model to train it so that the machine knows this is a positive review, this is a negative review. I will only show the training set, but the testing set, I'm not going to show it. I'll use for testing that to know how accuracy it had predicted. So we created a training set, and this is the first, like earlier we had tokenized already. First, this is false classic. This is this is actually a Boolean which return this is a positive review or not. If it's a positive review, then it will return true. If it's a negative review, then it will return false. Meaning first, I'm not sure about first, but definitely it returned false, but classically to return true. Irish, shady, and all that stuff. Let me see if I can find another true review. If I can find one. Uh, if I find one. That's not a whole lot. It seems like the first review contained a lot of negativity. Um, okay. I couldn't find one. I don't waste your time, but I understand you. We pretty much got the idea. Then we'll train the model using one of the libraries. We'll go over we use naive bias. For those people who have been to machine learning, I don't want to keep repeating myself on that. Then we test the accuracy, meaning that the higher the score, the accuracy it is. Nltk classify in LTK. I'm pretty sure in machine learning we do some other ways. The accuracy, then you pass takes two parameters. The first one is the trained training set, and it gets match up with the testing set, the data that the machine haven't seen yet. And the accuracy we get is actually how accuracy it is, the testing set compared to the training set. Times 100, meaning that it returns a 0 point something decimal. So to get to the percentage world, pretty much can be understood is actually more likely between positive and negative review, a unique is more likely to be a positive review than compared to negative. Worst is more likely to be a negative review, more likely than to be a positive review, meaning that when a machine actually sees these type of words, is actually help them to understand this is a positive or a negative review. So for people, I'm not pretty sure, or I'm not the big media guy, but for those who are using WhatsApp or any other social media stuff, when you type is actually, I believe, there should be a way to know that this is maybe this is not a good message to be sent out to other people. So that message get canceled right away. And I believe they're going through the same type of channels actually I just went over. Then we trained through other few models, the multinomial naive bias. I'm sorry, I had to input some other modules like the sklearn classifier, multinomial naive Bayes, which is pretty much with my not so much experience in NLP, I came to notice actually is used in place of naive Bayes. Logistics regression is just the same. SVC is just the same. Though we put the training set into different models and see which one performs better. So we did the same thing for multinomial. It returned 88.25 accuracy, which is a little bit more than the previous one that we went over. Then logistic regression returned 95.5 is likely to be accurate in predicting 95.5 we got the accuracy. It got the right, I think you understand me. So other modules, SGD classifiers and SVC actually performs in the 90s, but I'm kind of worried because there's a term for overfitting, but I'm not pretty sure. But this is what I was missing out few weeks back. Actually, it was something else. I had to create something else. This was meant to be presented a few weeks ago, but I thought I thought it was useful, and I wanted to share with every of my members. So that was all I had for today. So I welcome if there's any questions. I'll be likely to I'll be glad to answer. Thank you.
Okay, thank you, Christian.
Thank you. Thank you.
So, and I think the other time I had time to ask you a number of questions regarding to the topic. As I've said, yes, it's a very interesting topic for all of us, and especially yes, for the one who actually they are more focused on the machine learning, and it's very useful. And yes, currently, you can see that's the trend. And right now, there's a lot of groups that they're working on such projects, like to see how we can be able for everyone to use whatever the language that you want to be able to convey the message, rather than like right now, if you are in Chinese, probably you'll need an interpreter, a Chinese interpreter. So these ones, and of course, they have already implemented a number of languages, though now people are more into those can say minor languages. So yes, I can see it's very useful given the current situation that we are having right now.
Yes.
So congratulations for this topic. I hope you have done enough exercise on these ones. Yeah, so the other thing probably that this cut across to everyone, since this weekly talk now will be launched to YouTube channel, as we said, like yours, they're going to be combined, the first one and this one, then formulate a video. And this one, you can put it even in your profile, like in your, LinkedIn or anywhere that you want to, for anyone to be able to see what are you currently doing, or these are some of the topics probably you have been focused on. So it's kind of for you to gain traction and visibility. So yeah, what I'll request right now is to have like just 1 or 2 sentences on a summary of what the topic all about, and then so we linked it to the YouTube video. Yeah, so I think that one will be doing for this topic that we'll be presenting.
Okay.
Yeah, so yours probably, I don't know, it will depend now on Sam when we'll be ready. Probably next week it will be online. Yeah.
Okay.
Yeah, so I welcome the rest who has questions.
I can stop sharing, right?
Maybe you just leave it if there is anybody who want to go through it.
Oh, okay, okay, no worries.
So guys, do you have any questions or a comment? Wow, probably.
Yeah.
Probably this was more of us who are doing machine learning, but it's fine. So as I've said, we'll launch it. So you'll to prepare that 1 or 2 sentence paragraph, and you'll share it with Samuel so that it can be combined with the video that will be prepared.
Okay, thank you.
Okay. So I can see if there is no one who's having a question, we can just end up here. But it's nice work, and I can see it to be very useful, and probably if this is something that you really want, you can start tapping into the opportunity, because this is the current, I can say the current topic in town, people, what people they are doing right now.
Yeah, and actually, with all the people not aware of what to say in social media, not to say in texting people, can be very useful in blocking messages that are abusive messages, or like I mentioned before, fraudulent activities, people using text messages nowadays. So definitely it can be very, very, very useful. Yeah, especially in our nation, people who now actually, everyone is social media, he or she doesn't know what to say, what places. So especially young ones, can put them in a safe place. Yes.
Okay, this is an interesting one. Sawa. So thank you.
Okay, I can stop sharing.
Yeah, you can just stop sharing. So if there is anything out of the, and I'm stopping even doing the record.